Okay, everybody, welcome. Hopefully you're here for Programming Patterns and API Fundamentals. We'll be talking about the ArcGIS API for JavaScript. My name is Kelly Hutchins, and I'm here with my colleague, Renee. The important thing I want to point out to you on this intro slide is that the link to our session slides is available as a tiny URL there below our names, our Twitter handles, actually. So if you want to have the material to look at later, go ahead and follow that URL, and you'll find a GitHub repo with the information that we're going to present. So first, let's just do some introductory. What do you get with the API? With JavaScript API version 4.x, you get this simple and consistent API. So they've worked really hard to ensure that it's easier to use than the earlier version and that it's consistent. You can write apps in ES6 or TypeScript. There are sessions on TypeScript, I think, Thursday. So if you're interested in that, you should go check those out. It's supported in over 30 locales, languages. I added this here because sometimes if you work in the US, mostly with English-speaking users, you might not know this, but I think it's kind of interesting. I have just a quick example to show you. So here's a 3D app, a configurable app written with version 4x of the JavaScript API. And if you look at the title, that's in English because it's pulling the title from the person who created this application. But all of the other stuff, because I've said that this browser is running in a Japanese locale, it's maybe kind of hard to see, but you can see the search placeholder text is in Japanese, the tooltips are in Japanese, text on the widgets is all in Japanese, and you get that for free. And like I mentioned, over 30 languages. So I think that's kind of a nice feature. Let's talk a little bit about what options you have. There are a lot of options, and there's some things to think about when you're thinking about how you might want to get started building an app. What kind of capabilities does your app need to include? What features should it have? What resources do you have internally in your organization to work on building that app? How much time do you have to build it? And how much ability to make customizations do you have? So these are things that you can think about, and some of the things we'll show you in the next slides are ways that maybe if you don't have a ton of time or resources, you want to look at the configurable apps or the Web App Builder Developer Edition or Dashboard or some of the other things where you can get an app that looks really great up and running quickly with limited resources. If you have more time, you can maybe start customizing some of those apps, like the Web App Builder Developer Edition. You can maybe create a custom widget for your organization instead of building an app from scratch. Or maybe you have really specific needs and you need a really high performing application with just a few features, and then you might want to look at building it from scratch. But the key point, I guess, of this slide is that there are a lot of options available to you, and we're going to try and showcase a few of them in the next few slides. One place I wanted to point you to is the ESRI organization on GitHub. So like I mentioned earlier, why start from scratch, right? Maybe you don't have a lot of time, or maybe you just don't want to start from bare bones. You want to start with a starter app, or start with a widget that somebody else already built to plug into your app. So if you go to this ESRI GitHub repository, you'll see that we have a lot of things available out there. If I just filter on JavaScript, I think there's like 94 different repositories. Everything from all the configurable applications are out there. The source code is available. My colleague Ryan built this screenshot widget that uses the screenshot capability available in the 4x API, but he enhanced it so that you can include a pop-up or a legend. And he put that out there last week on GitHub. If you search for CLI, there is the ESRI ArcGIS CLI that Renee built. That's a great way to get started with a starter app. This thing uses TypeScript, Webpack, and a few other features. So it's got a lot of information in the README on how you can get up and running quickly with this app. So I think it's worth thinking about the things that your app needs to include, coming here to the ESRI org, looking through the available repositories and seeing maybe there's something that gets you 60% of where you need to be or 70% of where you need to be, and then you can just work on adding the extra capability. So widgets is sort of the next step. So if we're building an app from scratch, widgets are a great way to add a lot of functionality without writing a lot of code. So let's take a quick look at the API reference. And if we look at the samples and we just filter by the widgets tag, you'll see that there's a ton of samples. There's measure widgets and slice widgets that you can use with both 2D and 3D. There's sketch tools. There's, in the next release, editing tools available. There's location and layer list and legend and pop-up and feature and just a whole bunch more. So again, this is a place to come, check out all the available widgets, look at some samples, and take a look at the functionality that's available to you, and save yourself some time. There's over 30 widgets out of the box and more being added at every release. They, again, are like these building blocks of your application. You can just add a bunch of widgets in there and tie it together with a map or a scene, and you have a great app. I'm a big fan of writing less code, so less code for you to write. And all these widgets have been designed with building responsive apps in mind. So the pop-up does things like when you're viewing it on small screen sizes like a phone, it's dockable, so it'll dock to the bottom of the screen, so it's easy to read that pop-up content. And all the widgets, they keep the fact that we need to build responsive apps now in mind when they're designing these widgets. We're going to look at a few of the widgets. The first one I want to look at is expand. I think I use this the most. I think this is an example of a widget that we've probably all written the code for before, but it's nice to not have to do it anymore. So what this thing does is this is a button that you can add to your map or scene or user interface. You click that and it opens up a container that shows some content, and then you can toggle it open and close. So most of us have done that before. We've written a button, we've positioned it absolutely on our map, we've handled the logic for when people click it to open and close it. It's not hard, but it's an example of a repetitive task that we have to do, and now we can just use the expand widget. So I'm going to show you just a simple code pen with a few of the things that I like about the expand widget. So here we have just a simple map example. I have two expand widgets on my map. One of them opens up the legend, and the other one opens up the base map gallery. So it's a nice way to get that content out of the way when people aren't working with it, and when they do need to work with it, it's there. The nice thing is that these things have this, it's not going to behave for me. There it goes. So it docks to a drawer size at smaller screen sizes. I mentioned earlier that it was responsive. That's a behavior that you can turn off if you don't want it, but it's there out of the box. One of the common questions that I see maybe on GeoNet and from other developers I talk to is this. They'll add multiple expand widgets with containers to one corner of the API or the map. And when they do that, you can see that we have the base map gallery on top of the legend. So what we want in this situation is when you open one, we want the other one to close. So when we open the legend, we want the base map to close and vice versa. And the way you do that is with this group property. So all we need to do is come in here to our expand code. And for the ones that we want to work together to be connected, we just set group, and we can set any value. We just want it to be the same between the two. So I'll just call that value bottom left, and then bottom left. And now if I've typed everything correctly, when I open the legend, the base map gallery closes up. So you can give them any name you want. That string can be anything. You just want it to be the same for the widgets that you want to work together. The other thing that's nice about the expand widget is that if you're using it with one of the JS API out-of-the-box widgets, it will take the icon from that widget and use it in the expand button. So it might be kind of hard to see, but here we have base map gallery icon that we get for free. We don't have to write extra code. And then this legend icon. You could change it by specifying the icon class, but this is the out-of-the-box behavior. Another feature that I like is some of the widgets understand that we have content in ArcGIS Online and Portal, and they provide an easy way for you to work with that. So 2 examples are the search widget and the base map gallery. So the base map gallery has a portal property. If you set that to your org URL, it will pull your org's default base map gallery and show it in the base map gallery widget, so you don't have to do anything. Same is true for search, so let's look at that. Okay, so here we have the search widget. This is the default search behavior. It's just a box. We can type in an address. It's just the default world locator. But if I specify an org URL in the portal property, then I get any locators I have configured in the org, and I don't have to write any code that specifies the search sources. So here in this org, we have these 2 locators, San Diego and San Jose. They just show up in that search widget, and people can use them. I think I might have somehow oh no, there it is, sorry, okay. All right, now let's look at the pop-up a little bit. Pop-up, you guys have all probably used it. It's available. I don't want to spend too much time talking about it, but I did want to point out 2 features. One is this thing called menu actions. It's really easy in version 4x of the JavaScript API to add custom actions. These custom actions can be added to the pop-up, and they can do any behavior, a lot of different special behaviors that you want. So here we have the default zoom to, which is the out-of-the-box action that you get. And we've added an extra action that's measure length. So if you click on that, it goes and runs off and does some operation, measures the length of that line in this case, and reports the result back in the pop-up. Another thing I wanted to point out is that this current release, 4.10, if you have more than one action, we put this little 3 ellipses, and you have to click to expand that action. We heard from people that they want control over whether that shows up or not. So in the next release, that'll be something that you can opt into or opt out of. So you'll be able to just have those actions show up in that bottom area if you want. I think it's come up a couple times on GeoNet, so I wanted to mention it. Okay. The other thing is docking. I mentioned that the pop-up is dockable. So by default, it's responsive, and if you can see it when I went to a smaller screen size like a phone, the pop-up appears at the bottom of the screen. You can also specify that you want it to automatically dock in a certain location, like at the bottom left. But sometimes people ask on GeoNet or other places, I specify it to the bottom left, but then I still get this weird docking behavior. And that's because you have to actually, if you want to override it, you have to set this breakpoint property to false, and that will take away that default responsive behavior, and you can have your pop-up docked where you want it, explicit control over where you want it. So maybe think about it before you do that, but it's something that comes up occasionally. Popup template, this is what defines the content that goes inside that pop-up. There are a bunch of samples in the API that show how to create content for that pop-up. You can define fields, you can have custom HTML content, you can put charts in there, you can put other widgets in a pop-up. There's a sample that my co-worker will show at a pop-up presentation we're doing on Thursday, where she's got an actual map in that pop-up and it shows it as an overview map. You can use Arcade. If you haven't spent time looking at Arcade, I highly recommend it, especially if you're working with Web App Builder or configurable apps. Because the really nice thing about Arcade is you can do a lot of powerful stuff in those pop-ups, and that stuff carries over into the apps. So while it's not always easy to customize the hosted versions of those apps, you can add some custom Arcade to that pop-up, and it makes a really special experience or a really custom application. I have an example of that in the next slide, I think. I'm kind of lazy. If I don't have to write code, I don't want to. So one of the shortcuts that I use is authoring that pop-up content in ArcGIS Online. I can use the tools available in the interface to make the pop-up look the way I want. I can write the arcade expressions, I can test them out, I can write custom content for the description. There's a lot of stuff you can do. And then save that web map or scene and use it in your application, and you get all that stuff without having to write code. So here's an example of a web map. And I specified the base map in ArcGIS Online. I rendered the symbology in ArcGIS Online. And I configured the pop-up. And this is not a fancy version with Arcade, but I just want to show it to you really quickly. So actually, I'll show you the default table. So this data set is some information about projected finishing time for these participants in a race. And the target finishing time was given to me in hours. And I'm fine with figuring out like 24 hours is 1 day, 48 hours is 2 days. But after that, I have to start doing math in my head, and I don't like it. I don't want to figure out when they're going to finish if it's 69 hours. So if I just use the default pop-up, it would have shown 69 hours and 8 minutes. But what I did was I wrote an arcade expression in the pop-up. Let's see, I'm not sure. I have 3 arcade expressions. Let's see if it's the right one. Nope. Finish date. Okay, so you're a developer, so it's not, I mean, it's pretty self-explanatory. I think the help is really good. This one just does some date stuff on it and figures out like some date math. If this date is, you know, X number of hours, minutes, or seconds, extracts it out, and then we can display that information in a more user-friendly way. So here now, if I click on the pop-up, I can say that this guy Francis is supposed to finish the race Monday at 6:53 a.m. So that's much nicer than saying he'll finish in 72 hours and 15 minutes. I know explicitly or exactly what day he's targeted to finish the race. And I mentioned that if we do all that work in the web map, save that web map, here we have an application. This is one of the configurable apps available in ArcGIS Online. And if I click on a pop-up, I get that same information nicely formatted, and I didn't have to write the code. And if I want to make a change, I don't have to make a bunch of changes in my code. I can go to that web map and make the change there. So the feature widget is sort of related to the pop-up, or I think of it as related to the pop-up. A common example or a common question we get from people is, how can I create a hover pop-up? There are some situations where maybe you only have a small bit of information that you want to show in that pop-up, and you don't want people to have to click. You want them to be able to quickly move around. Well, the feature widget makes it easy to do that. It takes the Popup template content and renders it, in this case, in a panel. So you can see as we mouse around, we're getting this pop-up content. I think there's some things to think about when you build apps that do this. Number one is don't throw a bunch of content in there that people have to try and manage hovering and then scrolling through to see your content, right? So just test it out, see how it works for you. This is actually a sample from the help. And it's got a little bit of logic in here with working with the HitTest. It listens for the pointer move on the view. So that's right here. Actually, this code's kind of small. So it listens for the pointer move. When the pointer moves, it uses the view's HitTest to find out where that cursor is, and then gets the pop-up template from that feature and shows it in this feature widget. So it's only a small amount of code to get that hover capability. This is pretty nice. So with the widgets in 4X, they worked really hard to make sure they're easy for us to customize. So they consist of 2 pieces, the view and the view model. So the view is the presentation, and the view model is the business logic. So that leads to a lot of really nice things that we can do. So this screenshot is of the search view model. So that's the view model. That's the business logic, the logic for the search widget, which handles the search operations. So we'll take sort of a step back to the way we used to do it. So here's an example of geocoding. And this is still what you'll do if you want explicit control over everything. You want to customize a lot of information. So here's an example where we create the new locator task pass in our URL to our geocoding service, and we use the address to locations method, and we pass in an address. We then call location to address, and we get that information. But with the search view model, we can do the same thing. So we're just pulling that logic part out. We're not worrying about the search user interface. People in this example aren't typing an address in. We just want to do a search through code. So we create the search view model. We pass in the address, and it's going to give us back that information. So that's a really nice, quick way of working with, of doing geocoding. If you're working with online or portal, your organization has help or services, you can easily access those. So in this example, we're creating the portal. We're waiting for it to load. And then once it loads, one of the things that we get back, one of the portal properties, are the helper services. And this has got a lot of things like there's route tasks and other utility tasks, print service, geocoder service. So you can access that geocoder service from your org URL and use it with the locator task or the search view model. So there's two examples I want to show you quickly on the search or on the view models. One is a custom view, which is probably one of the most common ways that that view model is used. So this is a sample from the help that you can search for. And it uses the zoom view model, so that's the plus minus zoom controls available. And what it does is I think this is a React sample, it basically just changes the way that that zoom widget looks. So instead of the square plus or minus that we have in the corner that are stacked vertically on top of each other, we have these larger plus minus buttons that are down here in the bottom. And we can do that because of this separation. It's really easy to create our new look and feel for those zoom widgets. And in the interest of time, I'm not going to go through the code, but it's there for you to look at. This is a sample. And then the one more I wanted to point out, it's actually a sample that Renee, actually this is a blog post that Renee wrote with more information about view models. You'll find it in the blog or in the slides. You'll be able to look at those. Where is that thing again? Oh, so that's styling. Okay. I'll go through styling really fast because I know Renee's got a lot of information to present. Let's see if this is going to load. Well, I'm not sure why this is not loading. I'll have to look at it. But what this is, it's available in the slides, is a sample app that shows that there are a bunch of different themes available in the JavaScript API out of the box that style all the widgets. So there's a light theme, a dark theme, and a bunch of different colors. This application is a theme tester that has a drop-down box that lets you quickly look at the available themes and see how all of the widgets look with those themes on them. So you can check this out in those slides later. The one other thing I wanted to point out, how many of you work with Sass? A couple people. So if you want to create a custom theme, you can do that. There's a theme utility available that Franco wrote. It's available in GitHub in his personal repository. And what you can do, I have this up in Visual Studio Code, you can download that GitHub repository, install it, using npm install. It's going to run through and set up some files for your custom theme. Create this sample app that shows the widgets and the themes. And then we can make some modifications to this Sass file and create a custom theme. In the interest of time, I'm not going to do too much with it. But what I did was copied one of the other themes here. I think this is like the dark gray. And then you can change some of these properties. And there's a whole bunch more you can do. He outlines it on that page. But let's save this. And we should, if everything's going to cooperate, Well, these should be orange right now because I changed the text to orange. I'll have to look at it and see why it's not saving. But you'll just make some changes to those variables. This page reloads. You can see those changes and you can kind of play around with it and create a custom theme. So that's nice if your organization has branding or colors that you want to quickly apply to all of the widgets in the API. You can do it with this Sass file, and it spits out a CSS file that you can use in your application. And I'm going to turn it over to Renee.
All right, cool. Let me borrow that.
Oh, yeah.
HDMI. Nice, thank you. All right, awesome. So we're going to talk a little bit about some other parts of the API, get into some patterns as well. So one of the fundamental parts of the API is going to be the map and the view, right? You may have heard us talk a lot about this before, but basically the map is kind of a data model for your views. This also goes for scenes. They just hold information about what is going to be drawn. They don't actually do any drawing. So you can load a bunch of maps up and collect all information on the layers and use them, but you won't see anything until you add them to the view. But the APIs are pretty great because if you notice here, I can create a map view or a scene view, and there's no difference in the APIs for these, how I built them. Now, the scene view has a few more things you can do with it, but all of the properties available on the map view are also available in the scene view. So there's a consistent API between how you're going to work with these two different type of views for your maps. So base maps and ground, right? So you'll see here we have a bunch of convenience strings for base maps. We have things like streets, we have streets vector, streets navigation vector, topo vector, and so on. And under the hood, we actually have the ArcGIS Online item IDs or directly to the URLs for these base maps. So we'll load them for you. And again, these are just convenience strings. The same goes for the World Elevation Service. It's a convenience string in the API that you can use to build your apps. Ideally, though, you're not going to use these. Ideally, in a production environment, you would do everything on your own, right? So you're going to create a base map. It has an object called base layers, and this is going to be any kind of aerial imagery, raster tile layers, maybe some vector tile layers underneath, and then a reference layer that might be layers related to your labeling, right? So you have rasters or vector tiles of just annotation that you can load as a reference layer. And the same for the ground. So the ground, you would directly reference the elevation layer URL. And the reason for this is that as the API updates, the version 4.10 of the API is always going to point to whatever current base maps you have available. So if you update your code to say 4.15 down the future, those base maps have probably been updated at that point. Then we're not going to be pointing to the new ones. We're still pointing to the old ones. So you'll have to manually do this anyway when you update your code. So we always recommend that you manually create the base maps and the ground layers yourself, so you're always up to date. You don't have to rely on us to do this for you. Again, they're convenient strings meant for development, but try not to push that into production. So here's a sample of how I did it for a little app. So I've got a base layer that's going to be a tile layer for the topography, and I have a vector tile layer that I'm loading by the item ID that just sits on top of it for my topo. And that gives me a really nice visualization. So I have this nice elevation or like a hill shade underneath my vector tile layer, and it just kind of blends well together. So this is the kind of way that you would want to deploy your apps for production. Collections. So collections are really cool in the API, and you'll see them used a lot in the API. They are array-like, right? So they basically have all the same functions as arrays. They have all the same current array methods like find and so on, every, some, but they are a little bit smarter, right? So things I can do in a collection is, for example, I have an array of item IDs, and I essentially want to create these objects for my item IDs, right? So if you'll recognize this when we loaded layer items in the map or the layers before, you create an object with portal item with an ID on it. So I'm going to map over this array and create a bunch of portal items for them. So I'm going to cast these to something. So what I'm going to do is I'm going to create a web map collection that's going to be a collection of type web map, right? And then I'm going to go ahead and pass that array of item IDs, convert them to those little objects I showed you, and pass those objects to my collection. Under the hood, we're going to instantiate a new web map for every one of those, because I've told it to be a collection of a type. So that way you don't have to do it. Now when you do that, you have all these different web maps available for your application you can use and load them anytime you want. You can do this for pretty much anything that can be instantiated as new. You can pass it as an of type. So it's a really useful way to use the collections in your own applications. We do this a lot under the hood for different things like graphics, symbols, and so on. So you can definitely take advantage of yourself. Accessor. You might have heard us talk about Accessor quite a bit. Accessor is kind of the core for the API. It lets us do quite a few things. And one of those things is the fact that these, the properties on these accessor objects, they can be read or they can be set, right? So getter setters or read only, okay? And we also have constructor arguments. So we've kind of moved away from multiple argument constructors. So when you new something up, you don't typically pass a URL and then maybe a number and then some options. You just pass an object and provide properties on that object. We've kind of moved to that kind of pattern throughout the entire API. They're also watchable. And this is where the important part comes in. This is where all the really cool stuff starts to happen. They're observable. So you can watch for property changes to happen. You can do some other really cool things with it. So here, for example, I have a layer and I've got an opacity, I've got a title, I set those. I can just do them by individual properties, but you can also use a set method. And you can use that set method to set multiple properties at once. You just call the method, pass an object with the properties you want to update, and we're going to update those properties for you. We also have a get method, so you can do gets of nested properties. So I want to get the views title of the base map that's on my map, right? So you just pass that string in there, and you can get that property. You can also set deep properties that way. Just pass the string to the path of the property you want to change and the new value, and it'll just work. It kind of saves you from writing a bunch of code. It's a nice pattern to have in the API. You can watch for changes. So you want to watch for when the scale is going to change. When you do that, you're going to get the new value. You'll get the old value. So maybe you want to compare the two. Maybe you want to check, has the scale, well, it should have changed, but maybe you want to make sure it doesn't change beyond a certain limit. And then you're going to get the property you're watching for, which in this case is going to be scale, and then the target. The target's going to be the map view, right? So you have access to all these different properties coming back from these watchable properties, which means that you have a lot of flexibility to do some pretty cool stuff in your applications. It's really kind of cool and fun the way to do these things. You can watch for nested property values. I can watch for the title of my base map to change on my map view, right? I don't have to watch map.basemap.title. I can just watch it on the view. And we have these utilities in the API, watch utils. So maybe you're concerned about when a property is going to be true. Instead of checking the property value, is this value true or not, we have a when true property value. And we have a lot of these different watch util methods. We have once, so if you only care about when the value changes once, we're going to go ahead and watch that value one time. We're going to remove the handler for that, and then it's just going to get garbage collected later on. When defined once, and so on. Some of these return promises because they are just going to happen once, right? So when once, when true once. Things that are going to happen multiple times are going to be callbacks, because once a promise resolves, that's kind of it. You can't resolve a promise twice. So those are the ones that are going to use callbacks, and they're going to happen multiple times. Autocasting. So we have autocasting in the API, and you've probably heard us talk about it quite a bit. This is an example of how you would create a simple marker symbol in the 4x API versus the 3x API. So you would have normally have had to create the marker symbol with, tell it to square, create a simple line symbol, and that simple line symbol is going to have new colors in it as well. And this is still perfectly valid. You could do this in 4x if you wanted to, but you don't necessarily have to. You can just pass these objects with a type of simple marker. Again, the colors are really cool. The color, if you give us like red, white, or blue, we're going to know, we're going to read that. You can also give us a hex color. You can give us an RGB value, RGBA, and we'll automatically be able to read those values into the color and give you the right thing back. Promises. So we use promises throughout the API, everywhere. I mean, they are everywhere, right? They're on the views, they're on the maps, they're on everything. So the way you work with asynchronicity in the API is that a promise is going to be thenable. It's going to have a then method, and then if you want to do error handling, you'd use catch, right? And unlike maybe some other languages, well, let's not worry about that. You just do then and you do catch, right? So you have something to handle your result and something to handle your errors. We don't really rely on events too much, and that's not to say that there are no events in the JavaScript API. There are events. We just don't rely on them for places that we don't need them. So there are events where they make place. For example, there's an event on the map view for when a layer view is created. You can listen for every layer view to get created and then check if that's the layer view you're interested in. There's events on the sketch widget, for example. And the sketch widget has events because events that things are happening. So where they make sense, we have them, but otherwise everything's going to be a promise. So this is how you do promises with async await. If you have not used async await yet, it's an ES6, maybe 7, ES6 feature. It's been around a while. You can use it in TypeScript for quite a while. It's a lot of fun. Async await kind of makes your code look synchronous, even though it's not. In this case here, I have an async function that I'm going to pass a query to. And inside my async function, I'm now allowed to use this await keyword. So I'm going to say that my results are going to be the result of the await of layer query features with my query, right? And then I can get my results and I can return results. One thing to know is that this await, this is blocking, right? So if this does not resolve, it will time out and it will block any code after that, right? So what you would normally do is, if you're concerned about that, when you call do query, you would wrap do query in a try catch. So you can try to do a query. If it errors out, you catch the error and then you do something with it, right? That's where you're going to do your try catches to do error handling with async await. So I mentioned before, we have promises all over the API. They're used for loading resources. So when you create a map, we don't just start loading all the layers for that map right away that you may have given us. We just kind of let it sit there and waits. We get some basic information. So like when you create a web map, we get some information about the web map itself, but we don't load all the resources immediately. We just get some real basic info on it. And then once you add that map or web map to a view, then the view is going to load all the resources needed to be able to draw the map and get all the information and how it's supposed to be displayed. The extent, the projection, spatial reference, the number of layers it has, what are the capabilities of those layers, and everything else that we need to do. That's what the view does with the map when it has it. We have on the view this method called when. So view.when, it's not view.then. It used to be view.then way back when. We had to change it. That was a mistake. It's not our fault. The promise spec changed on us after we already did everything. So don't get mad at us, please. But there's a view.when, and view.when returns a promise. You can do view.when.then if you wanted to, but yeah, I mean, just do view.when. It's fine. It's not a big deal. So this is an example of how you could chain your promises, right? So I've got view.when, and then I want to get my layer views, so I'm going to do a view.when layer view, ask my map to give me a layer, and then that's going to return my layer view. Then I want to wait for the layer view to be updating, which is a completely separate discussion. If you're interested in how layer views and stuff work, hit me up at the island. When it's done updating, and that's false, then I get my result back for my layer view. And I can start querying the features from the layer view. So then I'm going to query the features of my layer view. That's another promise. I'm going to do something with those. And if at any point in my promise chain something goes wrong, I catch it with my error handler down at the bottom. Right. So that's one thing to do. If you're chaining promises and you put a .catch at the end, it'll just catch any error that happens along the way, which could be good or bad depending if you need to know when something went wrong. how you do that in async await, right? So similar like I showed you before, I'm going to await inside an async function. Every time you use await, has to happen inside an async function. You just can't do it outside of there. So I'm going to wait for view.when. I'm going to wait for the layer view, and I'm going to wait for when false once, and I'm going to wait for the query features, and then I'm going to do something with my features. And again, you can see at the bottom, I've wrapped all that in a try catch, just in case something happens to go wrong. This is kind of how you can move from using promise chaining to using async await in your apps. So different patterns in the API. Let me just check my time here. Oh, we got time, not a problem. All right, so events in the API. I mentioned we do have events. We have events where they make sense. You have events when you're interacting with the map, for example. So view on drag, we have an event for that. There's view on click, view on double click. We saw pointer move and so on. We have a whole list of events in the API documentation. So if we come over here on the map view, we've got all these different events that you'll be able to see. Some of the events will return a map point. So this is real useful if you're going to do something like pass that point to the geometry engine. You already have the geometry and you can do something with it. You can buffer it, collect a bunch of points that someone's moving around the map, and maybe you're going to want to pass those, or not pass the geometry engine. Let's get crazy. You want to do your own drawing, and so now you're going to create lines, geometries, and you're going to pass maybe that to the geometry engine as a line and do some sort of buffer on that. I mean, there's a ton of stuff you can do when you start interacting with the map view. That's how we're able to do these really cool interactive demos that we've been showing you at the plenary and all the sessions we have this week. So that's kind of how you work with interactivity in the map. This sample here, like for drag, you might have the need to stop propagation of that event. So that'll prevent any default behavior here. So then when I do view on drag, I won't actually be dragging my map, right? We have a sample in the SDK that kind of shows how to disable panning the map around and stuff like that. It's not really a map.freeze or something, but it's just kind of, it's cool. You can check it out. View events, so this is kind of how you work with the HitTest. HitTest is how, so we have an identify task. An identify task is going to work against services. But we've already got data on the client, so you don't need to go back to the server for all this stuff. When you do a hit test, you're going to give us the screen point. That's kind of a key here. We need the screen point. So you can just, if you do view.onClick, I actually create a screen point object. You don't have to do that. Just pass us the event because it has the X and Y in there, so we'll know what to do with it. And we're going to go ahead and we're going to look at all the layers that are in the map, and we're going to grab all the features from the different layers that are on the map. Note, if you have a feature layer or a graphics layer with graphics on top of each other, we're not going to grab them all. We're just going to grab the topmost one. Because, and I've had people do this, they've got some like, you know, either a work orders or service requests or some sort of system that draws like thousands of features on top of each other over a time period of like years. We're not going to go ahead and grab all that. All right, we're going to grab the topmost one for you, and you know you can do some magic on your own if you really wanted to. It would really kill the performance of your apps if we took care of that part of grabbing all of the features in the layer that are sitting at that point, right? So the hit test returns the topmost graphic per layer that's in your map. That's where you're going to get back a results array. That results array is going to represent every layer in the map, and it'll have the graphic that was part of the hit test result. And then you can do some really cool stuff with that hit test yourself. So there's a sample in the API with these lines that we've got here. And as I kind of hover over them, I do a hit test. I'm able to go ahead and change the symbology of that feature I'm hovering, and then display some information for it in a little viewer I have at the top here, right? So that's kind of cool. GoTo. So you're going to use GoTo a lot for not necessarily panning, it's not panning, but this is just kind of a nice way to seamlessly go from one location to another in your view. And you have control on whether you want this to be animated. Do you want it to be just kind of like go from here to here immediately, or do you want like a slow transition? You want to kind of ease your way to a location, right? We have all these easing functions you can pass to it, or pass your own custom easing function because you want to drive your users nuts. You want the map to kind of bounce around as they move from location to location. You can do that. It's up to you. I'm not going to tell you how to do your job. So we have a scene view here where we've got some flights. I got a default flight where I just kind of move from one spot to spot. I got a linear fast one. I mean, that's kind of silly. Exponentially increasing, right? So this is going to exponentially increase the speed of my go-to over the time period I've told it I want to animate that, right? So that's kind of cool. And then we got a bounce, because, you know, who doesn't like a good bounce inside their apps? Especially if you got a globe to work with. It's kind of cool. You can do all that, and it's a pretty powerful feature that we have in the API to do. Loadables, no, I'm going to go and skip over loadables. The key here, I kind of covered it with promises, is the fact that you can you can create a web map without loading all the assets, and you can load them later on as you need them. And that's with the .load method. So that happens in a lot of different places. I have a small sample here where I create my web map, I load it, I get features, and I query the features. Kind of straightforward. We've already kind of seen this with layer view. This is the same thing, just with the web map itself. All right, so I want to kind of talk about these, because these are kind of like some interesting patterns here. When you're working with zoom or scale, you'll see us use zoom in our samples a lot. And they're perfectly valid. You can use them in production, it's fine. Just understand that zoom is not scale, right? Zoom is going to be the level of details of your tiled base maps. If your tiled base maps are different for whatever reason from our tiled base maps, then your zoom level 14 may not be the same as our zoom level 14, because you cooked your base maps differently, right? Not LODs are created equal. You're really much safer using scale, because scale is portable. Scale, by definition, is going to be the same whether it's my map on my desktop, my map on my browser, or so on, right? So scale has meaning. The LODs don't really have a meaning, right? I mean, even though they do have a kind of predefined scale with when you cook them up and stuff like that, it's just it's safer to go with scale, is my personal opinion. If you give us an odd scale that's maybe not, we're just going to zoom to the nearest LOD, you can turn that off. All right, there's a way to do that with the API, and I forget, it's an option on the view that I forget to do. Hit me up if you're interested in that at the island. I can definitely show that to you. Web maps. So I know we have web map and we have map. A web map is still just a map. You don't need to have a portal item ID if you don't want to on the web map. You can just pass the base map, give it some layers, and it'll still just work. There's a couple advantages to using web map though. Web map has bookmarks already built into it, right? Bookmarks are not on a regular map, but they are on web map. So with this case here, I've got a web map, and essentially all I did is, it's a web map that's not pointing to a web map ID, but I've just got bookmarks I added to that web map that lets me use it now, right? So this sample is going to be in the slides. You can check it out. It's kind of cool. It's a neat feature you get with the API. Sublayer to feature layer. So if you did not know, map image layer is the ArcGIS dynamic map services, and they have a bunch of sublayers in them. You could actually, in the map image layer, grab a sublayer and create a feature layer from that. Now you have a feature layer. You can add that to your map, and you can start doing all this really cool client-side stuff that you would normally get with just a regular feature layer. It just works, right? Everything just kind of comes together. It's a beautiful part of the API. So I've got a sample here where what I'm doing is I need to do my renderer. So the smart mapping tools in the API, they actually take feature services or feature layers to create the renderers that you're going to get, and then you can apply them. So what I do is I go ahead and I'm going to get my, let's see here. So I get my layer from the sublayer. I create a feature layer from that. I'm passing that feature layer to the parameters of for my smart mapping tool. And then I'm going to use the smart mapping tools to create a renderer. But I'm going to take the result render and apply that to the sublayer of the map image layer that sends it off to the service and gives me back a new rendered image that can display my map. So this is how I'm not displaying the feature layer. I just use it for the smart mapping tools. It's a great shortcut that you can do to take advantage of smart mapping for your dynamic map services. Create query. If you didn't know, you can use the create query method for a layer. And the benefit of this, sorry, the benefit is that the query you get back is going to have any filters or definition expressions that were defined on the layer when you first got it. So maybe you didn't create the layer, you got it from online, it's published as an item. You pulled it in. There's some layer definition expressions on that. You want to do some queries, but you don't know what those definition expressions are. You don't have to recreate them. Don't worry about it. We're going to run all the queries, and they're going to honor the definition expressions that have already been applied to the layer for you. And if you don't care, just create a new query and do what you're going to do anyway. And nothing's predefined. So it's just a sample here where we're going to go ahead and we've got some well buffers I'm going to do. And I'm going to create query here. And I'm going to query my earthquakes and stuff. And this is just using the create query method from the layer to let me do that query because there's already a bunch of definition expressions applied every time I update stuff in the UI here. Again, this sample will be in the slides. Map image layer, let's see how I do on time here. So okay, I got a few minutes. I'll slow down a little bit. So if you want to modify the sublayers themselves, so in our samples, you'll see us a lot of times we define what the sublayers for the map image layer are, and that's kind of just a shortcut. It's perfectly valid. You just need to know that if you've got a sublayer with like 200 layers, but you've only defined maybe 4 of them in your map image layer when you create it, you're not going to get those other 194 because you defined 6, for example, sublayers, and you have 200 there. You're overriding what the sublayers are going to be when they come in your app. So if you need, God forbid, if you need your 200 sublayers displayed in your dynamic map service, but you only want to modify a few of them, do it after the map image layer loads. So after it loads, you can go ahead and then modify the sublayers. That way you don't overwrite the defaults for the entire sublayers, right? So let's run this one here. You'll see what I'm doing here is I get my layer, I'm going to load it, I'm going to find my points layer, and I'm going to apply a pop-up to it because it doesn't have a pop-up applied initially. I just want to give that first layer a pop-up, and then I'm going to add that layer to my map now, right? So I load my layer, my map image layer, I find the sublayer, give it a pop-up, and I'm good to go. So I don't want to overwrite the defaults because I've got other layers as part of my map image service. I just need to give one of them a pop-up. So this is an easier way to do it than maybe predefining 10, 20 different layers just to give one of them a pop-up, right? This is a great way to do it. Layer views, right? We kind of talked about layer views a little bit. You need to know when a layer view is done. I kind of showed you when that updating method is false. Hotly debated topic because, I mean, it's done gathering data at that point, but it may still kind of, depending on the amount of data you have, it may still be drawing. So there's that. But it's done updating, I swear. So when can you actually use it? So those are a couple different questions you want to ask. And the behavior is different with the optimized feature layer because we are going to grab as much data as we can with the dynamic feature tiles and everything. So there's a lot going on there when that's happening. So just be aware of that. But here we've got this layer views. I'm going to use when false once from the watch utils. I load my feature layer. And then I'm going to go ahead and when I'm going to get the layer view when that layer is done. So that when the layer view is ready to go, this is going to come back. But then I got to wait for it to finish updating. So at this point, even though I got the layer view's been initialized. It's probably still going out and fetching some data. So when it's done fetching data, I now can go ahead and I can query that layer view and do something with this. I can query the extent because now I know the layer view, once it's done updating, should know what the extent of the data is. So I can query that information. I can zoom to my visible layer at that point, right? So that's kind of how you can do that. It's kind of cool. That was it. Oh, I came under time. Awesome. All right. So yeah, that was it. Those are all the fundamentals, patterns, using the widgets, configurable apps and everything. All the stuff you have access to build some really cool apps. So we have a few minutes for questions. If anyone's got anything, please speak up. It's kind of hard to hear from up here down there.
They have 2 microphones, actually. One there and one there.
Oh, that'd be great if you wanted to walk to a microphone.
Or you can shout.
Can you go back to the first slide with the link to the slides?
Oh, sure. Yeah. There we go. Awesome. Yes, question. So if you need to support a browser, it's not ECMAScript 6 compliant, do we support translation with all this? So the JavaScript API supports Internet Explorer 11 plus, when we say plus, that means Edge, as well as all modern browsers, so Chrome, Safari, and Firefox, and so on. So yes, IE11, we've got stuff in there to make all this work. Things that will not work in IE11 are going to be the client-side projection engine, because that is WebAssembly. So that's like the one thing that wouldn't work. WebGL performance isn't great in IE11, but it does work. Yes. Yes.
Hey, cool talk. That was my microphone test.
Yes, very good.
So you mentioned working with the sublayers, and that was on a dynamic map image service?
Yeah, so we changed the name 4x. Instead of being called ArcGIS Dynamic Map Service Layer, it's called a Map Image Layer now. Yes.
So what's the best method for getting at, if you have a non-dynamic map service and it's got group layers, how do you get to the sublayers in there and start messing around with them?
Talking about like a non-cache tile layer kind of thing?
Yeah, the dynamic maps layer, but you can't dynamic. Wait.
Oh, I think it would. There might be some features that would not work in that case. So, like for example, when you define the sublayers in the map image layer, the order that you define them in is going to define what they're drawn in. But if you've turned that off, it should just ignore it. I don't know if the rendering capabilities in that case would still work. I have to double check. Can you hit me up after, because I need to double check with the person that wrote that.
I guess my question is more, how can I just get those sublayers as feature layers, given that it's like just get the REST endpoint or item ID in the portal of those sublayers?
I mean, you can always give us the URL directly to the layer itself, as long as that index is in the group layer, but like it would be the one under it, right? So if it's a group layer is 5, but you've got 6, 7, 8 are individuals, give us a 6, then you can make another one, give us a 7, another one, give us the 8. That would work, because all map services via the index can be used as feature layers as well.
Oh, so you get the index from the sublayer, slap that on the end of the URL, and
yeah, exactly. That will always work. It just wouldn't work if that index was a group layer. Then I don't know what error you'd get, but I'm sure you get an error.
I hope so. Thanks, man.
Yes.
You mentioned that for your accessors that they're observables, and that's why you're able to use the watchers. But I wondered if there was an easy way to convert them to like an RxJS observable.
Not an easy way. You could wrap them in RxJS observables, and just every time you want to have, you could subscribe to what you've wrapped it in, but every time you want to have that publish part of that, internally you'd have to do some sort of watch on the accessor part, and then have that do the publish part for it. I had a sample a while ago that did something very similar. I'd have to look it up though and see exactly how I did it.
Yes. Okay.
It's not exactly something that we have promoted or really talk about, but it should be possible. Yes.
Going back to the querying, there's some situations where you can't query a layer directly. You have to query the layer view. I think like a scene layer, for example, to run the query, you have to run it on the layer view. But then with a feature layer itself, you could query the layer, or you could query the layer view. I guess I'm not that clear. Where do you go? Where do you do things on the layer? Where do you do things on the layer view to get the results? Or does it matter for some of the ones where it won't error?
So it's the layer view, so client side, right? Layer view is if you.
Yeah, I'm trying to think of the situation with the scene layer, what that would be. I don't work with 3D too often, but
oh, sorry, I mean stream layer, not scene.
Stream layer. Stream layer might be a different story. I don't work with stream layer too often. We do support it, but I don't know about this querying capabilities on the stream layer. I'd have to look that one up.
I guess then what's the difference?
So the difference when in the queries, if you query the layer, we're always going to go back to the service to ask the service for those results. When you query the layer view, we are going to pull that result from the client that's already, the data that's already on the client.
Got it.
So when you have like a feature layer view and you do a query, it's not necessarily the data that's drawn, but the data that we have available. So you may have had an initial extent, we download all the data, but you've panned, we've grabbed more data. We still have the data that you had initially pulled down available for you to query as well. So that's the difference. The layer view does all its queries on the client, and layers do it all on the server. And Kelly has some stream layer.
I didn't see a query method on the Streamler. I'm not sure.
Right.
I'm not super familiar, but
If you get its layer view, which makes sense that one would go to the server and one would be client side.
Yeah.
So that's clear. Thanks.
All right, so, yeah, so stream layer
I think
may
for
not
Streamlayer, I'm not sure. If you come to the island, we can get an answer for you or find somebody who can answer that question. I just haven't done much work with it.
Cool. Any more questions before we close out? All right, awesome. Appreciate it. Thanks, folks.